Hello folks, this is Mr. Messerman with the Flipped Classroom podcast for our fourth quarter 2011. Music of Waters number 10. I can graph and interpret ice core data to determine the history of climate change on Earth. Well, the scenes I'm showing here are from the movie that we watched in class, but some of you didn't get to see the end, so I thought I'd put in the part about ice core drilling. An ice core drill rig basically bores down into the ice and pulls out chunks, sections of this ice from the drill core. These sections of ice are then packaged up and sent to a laboratory or carried over to a laboratory where they are analyzed for their content of chemicals and gases and dust and everything. When the snow falls, it traps air bubbles, and those air bubbles will actually be preserved in the ice for really up to millions of years. Here they're scraping it off clean. Here they're using electrodes to actually read the amount of dust in the ice cores, and the dust can measure cold and warm spells. Cold, dry spells tend to have more dust. So they can actually read climate just from the dust in the ice core. We're going to be concerned with carbon dioxide and methane and deuterium, which helps us measure temperature. And all these things can be measured in the ice cores, along with the age based on the layers of ice that deposited when the snow fell. Let's take a quick look at the atmosphere and sort of the greenhouse effect. Get this set up here. So here's the Earth, and we'll just use this purple line to represent the atmosphere. And the sun is in the sky. Let's get some sunshine coming down. So here's some sunlight coming down to the surface. Now, some of this sunshine reflects back into space from the surface and from the atmosphere and clouds, while some of it actually stays in. Let's change that to red. The red will represent heat energy that stays in the atmosphere. And that is in the entire troposphere is what we're worried about, is the troposphere, our layer of the atmosphere that we live in. The atmosphere actually absorbs heat energy as the sunlight passes through it, and it warms up. So we talk about Earth's atmospheric energy balance. And this is a balance between the energy that enters and the energy that leaves. And we measure it by average global temperatures. We can make direct measurements. Last couple of 100 years, we have actual temperature records from thermometers around the globe. Today, of course, we use satellites, and we have proxies, which are indirect measurements using isotopic ratios and other things that we find in the ice core samples. So what are the factors that affect the Earth's atmospheric energy balance? Insolation, the solar energy entering the atmosphere, reaching the surface. It's called insolation, sol for sun. That's in watts per meter squared. And then we have climate forcings. Positive climate forcings come from GHGs, greenhouse gases, like the big ones, CO2 and methane, carbon dioxide and methane, which methane is CH4. There are negative forcings as well, and those are tiny little particles called aerosols that reflect heat and reflects sunlight back into space. It can actually cool the globe. So positive warms and the negative cools. Sometimes they talk about global dimming. All right, in our lab, we're going to be graphing some data from Paleoclimate data sets that I've collected. The first one listed on the web page is deuterium temperature proxies, using deuterium ratios in the snow to measure the temperature. The second one is global CO2 emission estimates for basically the industrial age. The third one is global surface temperature anomalies, air temperature anomalies. Fourth is methane levels. The fifth is insolation values. The sixth is Mauna Loa CO2 measurements for the last about 50 years. And seventh is CO2 ice core data. Thanks for watching.